Number 35, it says factor completely. And the expression we want to factor is 60z to the 6th minus 118z to the 5th plus 56z to the 4th. You know that the German students who I have in my statistics class, in most of Europe, right, when they make a z, they have a little like cross.
Mr. Emperor does that.
Yeah. Most countries that have any brains do that, right? Because look, my z's look like 2's. You know, so you put the cross there and it makes it look like a z. Okay, so I need to factor this completely, which means that every term has to be unfactorable. So I'm looking at this and I'm saying I can probably divide by what? I can, in terms of a constant, can I divide by 6? Is 6 going to 56 8 times? Yeah? Is that right? Yes? No?
No.
7 times, yeah. You know, I'm not good on the multiplication table, right? So I can pull out a 6, I'm pretty sure. And what else can I pull out of this? Z to the 4th, right? So let's try that. If I go 6z to the 4th.
6 isn't going to work because it doesn't divide by 100.
It doesn't? Okay, I was taking a guess. So what is going to be my concept that I'm going to be able to factor here? 2. Just 2? Okay, so 2z to the 4th, and that's going to end up within 30z squared minus, what, 59? Oh, yeah, that's causing our problem. 59z plus, that's the end of the day. You know, my calculation skills are getting even worse, okay? Right? Does that look about right?
Yeah.
Okay. So I need to factor this some more. So I'm looking at this trinomial, and I know if I do my my guess method, I'll waste my entire time during the final doing that. Right? So I will go to the surefire method, which did I tell you that came from Mr. LeBron? No. Oh yeah. So yeah, the surefire method is actually Mr. LeBron's method. Right? So everybody give Mr. LeBron credit when I told him that they. Yeah. Thank you, Mr. LeBron. He's not the one who invented it, but he definitely used it, and it was my pre-calculus class that taught me that method. I didn't know that method before. At any rate, blah, blah, blah. 30 times 28. Can somebody pull out a calculator? Tell me what that is? 840. And then do we have any factors of 840 that would turn this into, that would add up to negative 59? I think I actually did this one.
I do that way.
Pardon me? You do it that way? Right.
But it's really hard to do.
It is harder, but it's easier than the guess method. So this is number 35. Did I do 35? I did. Okay, so I found them, right? I just kind of went through a bunch of them. What I did actually was I started with, just to show you my methodology here, is I started with 20 times 42. I just did this on my calculator, and that didn't work because those are 62. And then I just went up 1. I went up 21 and 40. And then I went to 24 and 35, because 24 times 35 is going to equal 840, and bingo, I saw it there. 24 and 35, those add up to 59. Right? We okay with that? You see how I did that? Questions? You sure? Okay, so now I still have my 2z to the 4th. And I have my 30z squared minus 24z minus 35z, because they both actually have to be negative, because I have to get a negative 59z, plus 28. So I'm going to group these like that. And I'm going to group this here But when I group this second half there, when I group this second part, remember I had plus 28, and I've grouped it now, so my negative sign is kind of, has to be allocated to both of these. So I need to change that plus 28 to a minus, because I grouped it. Does that make sense to everybody? Ask me a question. You see why I had to do that? Yes.
So it just turns into, so technically it'd be 2z4 times 30z to the second minus 24z, and then plus negative 35z?
Yes. Yes, that'd be the same thing. Yeah. Okay. So I've got that far, and now I'm looking at, I'm kind of leaving my 2z to the fourth over here to the side, 2z to the fourth, and I can see that from this part of the grouping, let's put it in a big bracket, I can take out 6z. And when I take out 6z, I'm left with 5z minus 4. Can everybody see that? Okay. And then minus, and I'm going to take out a 7 from this. And what do you know? 5z minus 4. So I've kind of attacked this trinomial here. First attacked the trinomial, and I turned it into two binomials, which I could then factor, and I'm going to wind up with this really nice expression here, which then to which I'm going to apply the distributive property. So again, I'm just going to leave my 2z to the fourth. I'll write it in just so that I don't forget it. And I'm going to pull out my 5z minus 4. And I'm going to distribute that times my remaining 6z minus 7. That's as far as we can factor this guy. Yes?
Why are you using the brackets? Could you leave those out, or do you have to have them?
You need to have, the reason I'm using the brackets is because if I didn't have either that bracket there or a, well, not, I tell you don't really need it there.
No?
No, because you need it at this level here. Because if you don't have it at this level here, then the 2z to the fourth, let me just right here. If you don't have it at this level here, then you're only applying the 2z to the fourth to the very first 6z. That's the only thing you're applying it to. You have to make sure that that you're applying it to this and to that, right? And that's why I use the brackets. Now you could use another set of parentheses if you wanted to instead of brackets. I just like to use brackets because it differentiates it for me in terms of the size of the area that I'm covering.
Okay, but once you get down to the bottom level,
No,
it's like you're multiplying all the way across?
yes, it's like I'm multiplying all the, because I could just get rid of the brackets.
Okay.
Yeah,
Thank you.
yeah, that's a good point. We good with this? Okay.